first section of our Probability 1 chapter is called Permutations, and in this section we'll be looking at the fundamental principle of counting, permuting a number of items, and permuting a set of items from a larger set, or we could call this permuting a subset of items. We'll start off with the fundamental principle of counting. The fundamental principle of counting is a complicated sounding name for quite a simple idea. It's the idea that if one event can happen in m ways, m just representing the number of ways in which it can happen, and another event can happen in n ways, again n just being the number of ways in which this other event can happen, then together they can happen in m times n ways. And this statement just covers two events, but this is extendable to any amount of events that you'd like. So in my example, a code is created by picking one letter between A and J inclusive and a number between 1 and 5 inclusive. And I want to know how many codes of this type can be made. So for my code, I have to pick a letter and I have to pick a number. How many ways can each be selected? Well, there are 10 letters from A to J, so I have 10 choices for my letter. And of course, there are 5 numbers from 1 to 5 inclusive, so I've got 5 choices for a number. And then I want to know how many codes I can make, so I want a letter and a number. So together, the events can happen in m times n ways. Well, I'll just multiply 10 by 5, and there are 50 possible codes that I can make. So here's your question. There are 4 types of cereal and 3 types of milk at a canteen. How many ways can breakfast be made? Pause the video here, work out your answer and check if you're correct. So I've got 2 choices. I've got to think about the cereal and the milk. Well, there are 4 types of cereal, 3 types of milk, and to find out how many different ways I can make breakfast with the 2 of those, I'll multiply to get an answer of 12. Next, we're going to look at permuting items. And permuting items just basically means finding out how many different ways they can be arranged. When we're permuting items or arranging them, the order in which they're placed matters. And here's an example. So in example 2 here, I have 5 books on my shelf. In how many different ways can they be arranged? So this type of basic permutation question is really an extension of the fundamental principle of counting. And I can lay it out in a similar way if I wish, by leaving a space for each item and then filling in how many different ways it can be put in. So in this example, I have 5 books to start off with. I'm going to place them on the shelf. So for the first position, I've got 5 different choices because I've got 5 books to choose from. Once that book then is positioned, I only have 4 choices for the next position. Once that book is placed, I have 3 choices, then 2 choices, and finally 1 choice for the last position. So to get my overall answer here then, I'm going to multiply my numbers together to get my solution. In this case, there are 120 different ways in which I can order those books on the shelf. In a straightforward question like this, I can also use a factorial approach. And factorial is just really a quick way of writing this calculation 5 by 4 by 3 by 2 by 1 down. Factorial is often written as n with an exclamation mark after it, which is read as n factorial. On your calculator, it can be seen here as x with an exclamation mark or x factorial. If it's a very straightforward question like this, where you've got a certain number of items and you want to know how many ways they can be arranged, just look at how many items you have, in this case 5, and calculate 5 factorial. Doing this the long-handed way just basically means starting at 5 and multiplying all the numbers until you get down as far as 1. Or you can use the calculator and you can just type in 5 shift factorial equals, and you can see the answer is 120. Just like in our longhand calculation here. So here's a question for you now. In how many ways can the letters of the word winter be arranged? Pause the video here, do your calculations and check and see if you're correct. So this time I've got 6 items and I want to arrange them in order. I can do my calculation in longhand like I did here, so 6 by 5 by 4 by 3 by 2 by 1. Or, slightly quicker, because it's a simple question, I can work out 6 factorial. So on the calculator that's 6 and then shift to get the factorial equals, and it's 720. Just a little side note here, 6 factorial is the same as 6 multiplied by 5 factorial. I'm using this dot here to indicate multiplication. We know that 6 factorial is 6 by 5 by 4 by 3 by 2 by 1. So 6 times 5 factorial would be 6 times 5 by 4 by 3 by 2 by 1. And of course, those two calculations are identical. So there were no restrictions or requirements in those questions. I just simply had to figure out how many different ways these items could have been arranged. but often we'll encounter questions that do have restrictions. So here's an example of a question with restrictions. I have 5 items on the mantelpiece. One of these is a clock, and I want to arrange them in different ways, but the clock must go in the middle. So how many ways can this be done? Well, this time it's less convenient for me to use factorial because there's a restriction in the question. So I'm going to think about those 5 objects or those 5 items and think about the different options I have for their positioning. Well, the restriction that I'm being faced with is the clock. I'm being required to put it in the middle. So I only have one option for that middle placement. So I'm going to fill a 1 in there. The rest of the items can be placed in whatever way I like. So starting at the beginning, with that clock out of the way, I now have 4 items. Once that item is placed, I then have 3 more items. With that out of the way, I then have 2, and then my final item gets placed. And like before, I'll multiply to get my solution. So there are 24 different ways that this can be achieved. So here's your question. How many arrangements of the letters in the word spring are possible if S must go last? Pause the video here, give a go with this, and then play and see if you're correct. So there are 6 letters in the word spring. So I've put 6 spaces down on the page. S has to go last, so I have no choice about that. There's only one option for that last position. And then going back to the beginning, well, there are 5 other letters in the word spring. So I've got 5 options for this first place. Then 4, then 3, then 2, and then 1. And again, it kind of harks back to that idea of the fundamental principle of counting, where we multiply our options together. And in this case, there are 120 different options. There are other types of restrictions we can also encounter when permuting in questions. Here's another example. In how many ways can I arrange the letters A, B, C, D, and E if A and B must always be together? I'm going to start by writing these letters out again. So there are 5 letters in this group, but I'm required to keep A and B together. So I'm going to think of them as being one unit of information. So now I've got 4 things really, 1, 2, 3, 4 that I want to arrange. So I'll give myself 4 spaces, and there are 4 options for the first position, and then 3, and then 2, and then 1. And these values will multiply together. And that will be all if A and B were staying together and A always came first and B always came second. But the question doesn't specify that. A and B have to be together, but A could come first or B could come first. So I must multiply my calculation further by the number of different ways that A and B can be arranged. And looking inside my little bubble of A and B here, well, I've got 2 options for what comes first and 1 option for what comes at the end. And now I can go ahead and calculate. So the 4 by 3 by 2 by 1 is 24, the 2 by 1 is obviously 2, and so there are 48 ways in which these 5 letters can be arranged if A and B must be together. Note that this calculation could also be written as 4 factorial times 2 factorial, which also equals 48. So here's a question for you now. In how many ways can I arrange the letters A, B, C, D, and E if A, B, and C must always be together? Pause the video here, try the question, and then play and see if you're correct. Okay, so I'm going to start by writing the letters down again. And I'm going to bundle the A, B, C together. So now by doing that, I only have 3 items that I need to arrange if I consider A, B, C as one unit. And so my calculation for that then will be 3 by 2 by 1. But then of course I have to consider the various different ways in which the A, the B and the C themselves can be reorganised within this unit. And of course within that unit there are 3 things again. So 3 by 2 by 1 to figure out the different number of ways in which those letters themselves can be organised. And then I'll multiply these 2 calculations together to find out how many ways the arrangements can happen if A, B and C must be together. So in this case, I've got 6 by 6, or 36 ways of arranging the letters. Again, you can write this down using factorial notation if you like, which would look like this. 3 factorial times 3 factorial equals 36. So finally, we're going to look at permuting a subset of items. This is when we have a group and we want to arrange some of the items, but not all. Before we begin to do this, let's have a look for the Npr button on the calculator. And you'll see that it's just here in the shift or second function of the multiply sign on the Casio calculator. So we'll press shift and multiply to get at it. We'll come back to that in a moment. So here's our example. There are 6 greyhounds in a race. In how many ways can the first 3 places be filled? Now I can go about this in quite a similar way to the previous questions. I've got 3 positions to fill, and I can think about how many options are available in each case. So any of the 6 greyhounds could come first. So there's 6 options there. Once he's crossed the line, there's then 5 options. Now we're down to 4 options, and that's the first 3 places filled. I'll multiply these numbers together to get my solution. And in this case, my solution is 120. So there's 120 different ways in which first, second, and third place could be filled. Now let's look at how to do this using the calculator, using the NPR button. So with NPR, the N represents the total number of items that I'm dealing with, and the R represents the number of items that I want to permute. And R is the number of items that I want to arrange. So I could say this as N permute R. And in this particular case, I've got 6 greyhounds, and I want to permute 3 of them because I want to fill those first 3 places. So I can go to the calculator and I can type in 6 and then shift the multiply symbol to get the P, and then 3, so that's 6 permute 3, hit my equals, and my solution there is 120. And you can see that this is the same solution as I got earlier. So I create a code by selecting 3 numbers from 0 to 9 inclusive, with no number being repeated. How many codes can I create? Pause the video here, do the question, and then check and see if you're correct. Okay, so I've got 3 different places to fill. There are 10 numbers from 0 to 9 inclusive. So I have 10 by 9 by 8 options. And there are 720 codes that I can create. That's one way of doing it. Of course, I can also use the NPR way, in which case I'd type in 10 permute 3 into the calculator to still get the same solution of 720 different codes that I can create.